Okay, here we go with section 10.2. This first part of the section has to do with special right triangles, 45, 45, 90 triangles. That means that we have an isosceles right triangle where two of the angles are 45 degrees each. Two of the sides are the same because it's isosceles, and we have one right angle. All right, so here we go. This conjecture says isosceles right triangle. In an isosceles right triangle, if the legs have the same length L. Oh, let's go ahead and make a drawing. Let's see what that looks like. Here's an isosceles right triangle, meaning that the legs are the same. If it has side lengths L, then the hypotenuse, well, let's identify the hypotenuse first. Remember, the hypotenuse is always opposite of the right angle. So there it is. This is the hypotenuse. Well, what do we know about the hypotenuse in this case? Well, turns out that the hypotenuse is equal to the square root of 2 times the length of one of the sides. What? Yeah, that's exactly what it is. You take the length of one of the legs and you multiply that times radical 2. In being that you're multiplying by radical 2, we're going to see if we can leave all of our answers, or most of them anyway, in simplest radical form, so you don't have to do any of that conversion stuff with your calculator. Right? So let's go ahead and give this a try. First, let's fill in this blank. This would be L, the length of the leg, times radical 2. So it's L radical 2. All right, so let's move on. Let's try some of these examples here. Here we have 3 right triangles. Looks like these two are missing the little right angle symbol. Let's start with the one on the left. The one on the left, we see that the length of the legs is, each of these is L. This is isosceles right triangle. Let's go ahead and just label this first one. This is 45 degrees. This other angle is also 45 degrees. If we add these up, 90 plus 45 plus 45, then you can check that this equals 180 degrees. So this is a triangle, and it is isosceles. All right. So now what we're told, the conjecture previously said, well, take the length of the leg, L, and multiply that times radical 2. Okay? Simple enough. If you can memorize it, that works great. If not, well, let's try it mathematically. Let's use the Pythagorean theorem to see if this works out. All right, so here we go. We're going to use a squared plus b squared is equal to c squared. And again, hypotenuse is c. A and b really don't matter. They are interchangeable. So here we go. A is L squared. B is L squared. And we want to see if this equals c squared. So c squared. It should be a 2. All right. So now let's go ahead and, well, L squared plus L squared is really 2L squared. That is equal to c squared. Now this is where it starts getting a little bit confusing if you're not too familiar with radicals, taking the square roots of stuff. So let's go ahead and take the square root of each of these. So let's say c is equal to the square root of L squared times the square root of 2. You might have caught what I just did there. I separated them and I switched them around just so that radical 2 is on the right. Now, let's clean this up. So that tells us that c is equal to, well, the square root of L squared is just L. And the square root of 2 is just the square root of 2. Ha! Check that out. That is true. Right? Then that's how you would do it if you didn't have any letters, any numbers, I should say. But let's take a look at another one. Let's take a look at an example with numbers. Just randomly, let's make these. These are the same because it's an isosceles right triangle. Let's say that these are 4. According to our conjecture, we have to take the length of the leg, which is 4, and multiply it times radical 2. That should be the length of the hypotenuse, right? Opposite of that right angle is the hypotenuse. If we use our conjecture, that's how easy it is. Take the length of the leg, multiply that times radical 2, and you have it. But let's say you don't remember. Let's go ahead and do it the old-fashioned way, the 10.1, using the Pythagorean theorem. In this case, a and b are the same, so we'll just go ahead and start with 4 squared plus 4 squared is equal to c squared. Now we're trying to figure out what the length of the hypotenuse is. Now, similar to the previous one, we have 4 squared plus 4 squared. That means that we have 2 of those, right? So we can just say this is 2 times 4 squared, right? We have 2 of those. Okay? That is equal to c squared. Now here, let's go ahead and take the square root of both sides. Let's not multiply that 4 squared and then multiply it times 2, because we're going to end up doing a lot more work than we have to. So what we're going to do is we're going to take this side and take the square root of 2, and we're also going to take the square root of 4 squared. Some of you might have caught that. That actually works out very nicely. The square root of 4 squared is 4, or you can say the square root of 16. Square root of 16 is 4, and then radical 2 stays as radical 2, and that is the length of c. And check that out, right? That actually works. Look at that. Good job, y'all. Next one, let's say you're still not a believer, but let me go ahead and give this another try. See if I can convince you that this really is, it works, that it actually is some good stuff here, because we know how great we feel about math. All right, so here we go. Isosceles right triangle, right? Sides are the same. That means that the base angles are also have the same measure. So let's go ahead and apply this Pythagorean theorem. But actually, before we do that, let's use the conjecture. The conjecture says take the length of the leg, which is 5, and multiply that times radical 2. All right. Now that's what it should be. Let's see if we can get that using the Pythagorean theorem, right? So what we have is 5 squared plus 5 squared. What does our hypotenuse equal? Because we don't know, so let's go ahead and figure this out. 5 squared plus 5 squared means that we have actually 2 of those. We have 2 5 squared, that 5 squareds, and that equals to c squared. That right there is very, very tricky. It might take a little bit of time to wrap your head around how that works, but just know that it works. Here, let's go off on a little tangent here and see if I can explain that. Let's side math, or let's see if we can do that. Now, notice that if we could factor out a 5 squared, if we factor out a 5 squared, we end up with 5 squared on the outside, and on the inside, let's see, take each of these terms and divide by 5 squared. Divide those by 5 squared, we end up with 1 plus 1. But what we know is that 1 plus 1 is 2, and then we can get back to there. So it's a real shortcut to doing all that math, right? So if you can do that, if you can understand that, you're on to great big things. If not, take the longer way until you can establish that, or you can see that pattern, and then you're able to move on. All right, so now let's go ahead and take the square root of each of the sides, and we end up with c is equal to the square root of 5 squared times the square root of 2. Well, the 5 squared is 25. The square root of 25, that ends up being 5. We got radical 2. That's equal to the length of the hypotenuse. And look at that. Yes, it does. Right? At any point, if you need to go back and take a look at the video again, or pause it, rewind, make sure you do so, because this stuff is... at first beginning, it's a little intimidating, but as soon as you get going, you'll notice that it's actually pretty good.